Yo, 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 this is Mr. O. And today we're going to learn about graphing quadratic function and its characteristics. We know quadratic function has a parent function of y is equal to x squared, wherein the graph is called parabola. Parabola can open upward or downwards. Okay. Graph y equals x squared minus 2. For this video, we're going to learn about 1-3-5 rule in graphing instead of writing a table of values. So in order for us to find the axisymmetry of our equation y equals x squared minus 2, we have to understand that the standard form is y is equal to ax squared plus bx plus c. For this problem here, a is equal to 1 because a is equal to 1, b here is 0, c is equal to negative 2. The formula for axisymmetry is x equal to negative b over 2a. So in this case, the b is 0 over 2 times 1. 0 over 2 is 0. So that is the axisymmetry, x equal to 0. For you to find a vertex, you need to plug in whatever your axisymmetry to the equation. So you're going to plug in the 0 there. That will give you 0 squared minus 2. 0 minus 2 is negative 2. Therefore, the vertex here is 0 from the axisymmetry, comma, negative 2. That is your vertex. Now, how do we graph this one here? So start from 0, negative 2, right here. That's your vertex. Applying the rule 1-3-5, this is telling you how much you go up or down. Depends if the parabola is going up or going down. Since the value of a here is positive 1, so we know it's going up. So we're going to go up from the vertex 1 over, then up 3 because it's 1-3-5. 1, 2, 3 over 1, and then up 5, 1, 2, 3, 4, 5 over 1. And then we're going to do the reflection on the other side, reflection over here, and there, here also. And then you connect the points. And that's your parabola. How do you find the y-intercept? The y-intercept is the c of your equation, which in this case is 0, comma, negative 2. So happen by coincidence that the vertex and the y-intercept are the same, but they're not always going to be the same. Since this opens upward, this is the minimum value. If the graph opens downward, the highest point there is the maximum. But in this case, it opens upward. This is the minimum value. For you to know the minimum value, whatever your y-coordinate of your vertex, that's your minimum value. So for this case, it's negative 2 because whatever that y value on your vertex. Okay? All right, let's move on here. Y is equal to negative 2x squared. So in this case here, we know y is equal to ax squared plus bx plus c. The value of a here is negative 2. The value of b is 0. C is also 0. So for us to find the axisymmetry, the formula is same thing, negative b over 2a. B here is 0 over 2 times negative 2. Whatever the denominator, which is negative 4. But if you divide it from a 0, the answer will still be 0. So the axisymmetry is x equal to 0. So in your vertex, write the 0 there already. You plug in a 0 to the x here. That will give us negative 2, 0 squared. That will still give us a 0. So that's your vertex, that black point there. The y-intercept is whatever the value of your c. So that will be 0, 0 again. And that is also coincident again for the second time. Since the a value is negative, so we know it's going to open downward. If it opens downward, the vertex here is your maximum point. So that's maximum. What's the maximum value? The maximum value is whatever the y-coordinate on your vertex, which in this case is 0. So here now, we're going to apply the 1-3-5. But hold on, we only apply 1-3-5 when the value of a is equal to 1. But in this case, the value of a here is negative 2, or absolute value of negative 2 is 2. So I'm going to multiply the 1-3-5 by 2. That will give us 2, 6, and 10. So from the vertex, I'm going to go down 2 because that's negative, so it opens downward. Down 2 from the vertex, 1, 2, left, down 6. 1, 2, 3, 4, 5, 6, left 1. I don't have a space to go down 10, so that's enough. I can just do the reflection. Down 2, 1, 2, right, down 6, right, and then I will just connect all the points, and that's my graph. Don't forget that the axis of symmetry is x equals 0, which on this case is the one that crossed the vertex there. Next, y is equal to negative x squared plus 4x plus 5. Again, in this case, the value of a here is equal to negative 1, b here is equal to 4, c is equal to 5. Applying the formula, x equals negative b over 2a, x equal to negative 4 over, oh, that's wrong, x equal to negative 4 over 2 times negative 1. That will give us negative 4 over negative 2, or just positive 2. So x equal to positive 2. In order for us to find the vertex, we know that this is already 2 because of the axis of symmetry. And for us to find the vertex there, the y-coordinate, we need to plug in the 2 right here. So negative 2 squared plus 4 times 2 plus 5 will give us 8 plus 5 here, and this will be 4, negative 4, and this will be 4 plus 5, which is 9. So therefore, this is 2 comma 9. And for us to find the y-intercept, it's always the c value, wherein the c here is 5, so this will be 0 comma 5. And since we know the value of a is negative, it will open downward. If it opens downward, this is your maximum value, which in this case is going to be 9, whatever that y-coordinate. So how do we graph it? We start at 2, 9. 2, 9 is right here. And we're going to apply 135. Since the 135 here is, the value of a here is 1, so we don't have to multiply the 135 by anything. That means it's going to go down 1 over, down 3 over, down 5 over. So from the vertex, down 1 over to the left, down 3, 1, 2, 3 to the left, down 5, 1, 2, 3, 4, 5 to the left. And then reflection on the other side to the right and to the right there. If you notice, the graph crossed the y value. What is the y value there? What is that one? That is 5. And look at our answer on y, on the y-intercept, 0 comma 5, which we got it from the c there. And then draw a dotted line that goes through the vertex that cuts a parabola into equal part, and that's your axis of symmetry, which is on this problem is x equal to 2. 2x squared plus 4x minus 7. Again, we know that the value of a here is equal to 2, the value of b is equal to 4, the value of c is equal to negative 7. Applying the axis of symmetry here, which is x equal to negative b over 2a, negative 4 over 2 times 2, that will give us negative 4 times 4, divided by 4, I mean, that will be negative 1. So therefore, the axis of symmetry is x equal to negative 1. And in your vertex, you're going to write here negative 1 right away. How do you find the y value here? The y value there is the value once you plug in the negative 1 to the x. So this will become 2 negative 1 squared plus 4 times negative 1 minus 7. This will become 1 times 2 is 2, negative 4 minus 7. Negative 2 minus 7 is going to be negative 9. So let's go to negative 1, negative 9. That is, no, that's wrong. Negative 1 down negative 9 is right here. That's your vertex. Since the y-intercept, the c is negative 7, so therefore 0 is negative 7 is your y-intercept. Since a is positive, it opens upward, so therefore this is a minimum value, circle the minimum, and that will be negative 9. Applying the 135, but since the value of a is 2 times 2, it's going to be 2, 6, 10. So I'm going to go up 2 from the vertex, 1, 2 over, up 6, 1, 2, 3, 4, 5, 6 over. And then reflection on the other side, reflection here. You don't have to do the 10. Connect, make it a U shape, arrowheads extended, kaboom. And don't forget to draw your axis of symmetry. And that's how you graph quadratic equation.